Hi students, today we are going to see about membrane fouling. I am Dr. S. Rekha, Associate Professor, RMK Engineering College, Kavarapete, Chennai. Let us get into the topic. Today's agenda is definition of fouling, types and mitigation, how to mitigate this fouling. So membrane fouling, first we have to know what is membrane. Membrane is something which is used in RO process, right? So for filtration of water, we use membrane in reverse osmosis process. So that membrane, due to number of time utilization, get fouled. What is fouled? Get damaged, get smelled, right? So it is not in its form. Why? Because it may be because of suspended impurities which stagnate over there, or because of dissolved substance which is also get deposited over the surface or on the pores or within the pores, right? Example, bacteria, clay, colloidal silica, iron, corrosion part products, etc. Okay, so these material get deposited over there. It may be a bacteria, it may be clay, colloidal silica, iron, etc. So how this membrane look like? See, this membrane, RO membrane has so many layers, right? So we have seen in detail in RO process. So now continuous utilization, the nearby picture, see, you can see how it is getting fouled. What is the picture now? After the utilization, see on the surface, you can see all the deposits, right? So it gets deposited over here. Filtration starts here. So it gets deposited over this surfaces here. So this is a fouled one. Okay, we need to clean it because membranes are very costly. We need to clean it and we have to reuse this. That structure tells, right? Types of fouling. We have four types of fouling here. We go first with particulate fouling. Okay, particulate or colloidal fouling. So as the name indicates, it is the suspended colloidal particle which is present on the surface water or the water which is being treated get deposited on the membrane or pores into the pores of the membrane. So how can it be removed? Easily it can be handled by systematically backwashing or air scrubbing. Okay, so let us see the picture how particulate colloidal fouling substance look like, right? See here, this is a complete total membrane fouling. So this is particulate fouling where you can see this material to be philic and hydrophobic in nature, just like mycelium. So head and tail part it is there. So this is particulate fouling. This way we represent the particulate fouling. Next one, organic fouling. Okay, so if we take water from nature, that is especially surface water, it contains abundance of organic substances in it. What are the organic substances present? Polysaccharide, protein, humic substance, nucleic acid, lipids, amino acids, all these are present. So all these while filtering get deposited on the surface or inside the pores, right? So we need to remove this, okay? So as we know, DOM, dissolved organic matter, is very high in surface water as well as wastewater. So we need to remove this. See in this picture how an organic matter which is present in water is represented. So this way it is represented organic matter having one branching over the surface. See here, so that is organic substances. Third type is biofouling, accumulation of biological growth in system or its attachment on the membrane. What is it? See, while we are filtering this water, so definitely it is going to have microorganism like bacteria, right? So this bacteria, when gets adsorbed to the membrane surfaces, in due course start emitting the certain material called extracellular polymeric substances. Okay, how these substances are? These are slimy gel-like substances. See, you can see on the membrane. So how it is gel-like membrane which is growing on the surfaces. So this membrane can retard up to 40% of the total fouling. So fouling 40% is due to only biofouling, and that too because of EPS. Shortly we call it as EPS on the RO process. Okay. So how it is represented? So here we have this microbial fouling. See, microorganisms. We draw this and we show that microbial fouling, how it is taking place. Okay. So all the four constitute here as a membrane fouling in the middle. Okay, we'll see the fourth one. So type 4 is inorganic fouling or scaling. So as we know, our water contains a lot of dissolved substances in it, right? Especially groundwater contains a lot of dissolved substances. So when these are filtered over, it contains a lot of low solubility salt in it. Okay, when they are filtered, what happens? They get supersaturated and get eventually precipitated out of the solution and get deposited on the surface. So we call this as generally as scaling. So we'll see in the picture. So here we have inorganic deposits, right? So inorganic fouling could be represented this way. So how to draw these things while writing an examination? Finally, when we have understood certain things, so we need to put into the paper, right? So colloidal fouling. So how it is scaling? So biofouling, okay, and then we have organic fouling, right? So in this way you can draw and express yourself. So how to mitigate this foul? So it can be feed water pre-treatment. That is while giving the water or input water itself, you have a pre-treated water so that fouling is very less, right? Operational condition optimization. So how do we operate this RO process? That can also minimize this fouling process. Then membrane cleaning, once it is fouled, we need to clean regularly. Okay, until last minute, you should not wait. Then and there, regular cleaning can also reduce this fouling part. Then surface modification. So the deposition, you can avoid it by surface modification of the membrane. So all this one, we'll see one by one. Membrane cleaning. First method is physical cleaning. So where physically we can clean off the deposit which is on the surface. So it could be by aeration, backwashing, or ultrasonic, sponge scrubbing, or water washing, right? So either of the method we can use to remove the major deposit on the surface. Then second method we have to go by chemical cleaning, which is finely deposited. So how to remove those deposition? Can we go by chemical cleaning? So here we have alkali cleaning as well as we have acid cleaning. So we'll see one by one what is alkali and what is acid cleaning, right? Let us see alkali cleaning. Okay. So alkali cleaning is basically sodium hydroxide uh, cleaning with sodium hydroxide. Okay, so how do we do that? We inject water into the membrane, okay, and we heat it with steam. Okay, we make it hot so that the cleaning process is better. Now we inject sodium hydroxide of 11 pH into the membrane, okay, and we have soaked it for 50 minutes and we check the pH regularly. If the pH is decreasing because of the reaction of the organic substance and biological foulant, pH will decrease. Okay, when it is decreasing by 0.5, again what we do, we add this 11 pH NaOH. Again, we allow it to stay for longer time, say 50 minutes. Okay, until pH is decreasing, we have to repeat this process. Once the pH decreasing is stopped, then we have to go for water washing. And we have to wash the membrane until it comes to a pH of 6 to 7 range. Okay, until then it should be washed. Now your membrane is alkali cleaned. So all the biological and organic substance will be 95 to 98% get removed off. Okay. Now we have acid cleaning. Okay, so removes mineral and inorganic substances. So it dissolves all the minerals as well as the inorganic substances in it, especially the inorganic part. Okay, scaling can be removed by this. The combination of alkali and acid cleaning may effectively remove all the pollutant from the surfaces. So let us see the process of acid cleaning. Okay, inject water, heat it with steam as it is similar to that of the alkali cleaning. Now add HCl of a pH range of 2 to 3. Okay, membrane is soaked for 40 minutes now. Okay, so now we have to check whether the pH is increased by 0.5. There it was decreasing, here it is increased. Okay, so if it is increased by 0.5, then we have to repeat the step. So again, we have to add a pH of 2 to 3 and soak the membrane for at least for half an hour. Okay, like this, we have to repeat it until pH is decreasing. Okay, once it stopped decreasing, then what we have to do, we have to go with water washing. So raise the pH up to 6 to 7. Clean it in such a way that pH rises to 6 to 7 so that all the acid is removed and membrane will not get damaged because of long lasting of this acid. Okay, we have to remove that. So this way we can clean this acid. So now, as I told you earlier, acid and alkali cleaning put together can remove 95% of all your pollutant. So it can be effective on the membranes. Now we have another methods, certain things where we can reduce this fouling process. Okay, one is feed water pre-treatment. Okay, feed water is usually pre-treated prior to its process. So see, number of colloidal substances. If you have taken minimum of it, then fouling is reduced, right? Disinfection, scaling, inhibition, hardness removal by lime, particulate removal by coarse strain. So all this, if you do it, pre-treatment process. So we can reduce the fouling process. Okay, or it will not be fouled very quickly. It will take longer time for fouling, right? Then operational condition like temperature, pressure, and hydrodynamic conditions can be optimized. So this we can take it from the membrane who has provided you the condition, how it could be operated, what is the condition so that membrane does not get damaged very quickly. Okay, fouling is part of damaging also, right? To improve the permeability or the quality. See, once they get deposited on the surface, the process gets slows down. So we want to avoid that, we want to reduce that. So take the operational condition from the company from which you are buying this membrane. So that also has an impact on the fouling part.